Hello, let's graph some sine and cosine functions that involve a change in amplitude and a change in period. So my first function, I notice that my value of b is negative. Okay, so here I have b is -4. We need to rewrite that because that means that is a reflection about the y-axis, and we do not want to do that. So we're going to use the fact that sine is an odd function. Recall that means that if I put in the opposite x value into the sine function, I get the opposite function value. So I can basically pull that negative out that's on the x and put it out front, and I have an equivalent form. So I'm going to rewrite that as y equals -1/3 sine of 4x. Okay, so ultimately my negative went out front on the 1/3. So my a value is -1/3, which tells me the amplitude. Remember, the amplitude is the absolute value. The amplitude is 1/3. And the negative tells me we reflect. Yes, we're doing a reflection about the x-axis. That's the only type of reflection that we actually do. All right, and my b value. My b value is 4. So to find the period of this new graph, I take the period of sine and I divide it by b. And if I simplify that, I get pi over 2. So this graph will make one cycle in pi over 2 units. There is no phase shift, and there is no vertical shift. So that means basically our phase shift, or that our cycle begins at x equals 0, and our midline is the x-axis, which is the line y equals 0. Okay, so there's no shifting left, right, or up, down. Okay, so what we need is we need to locate our 5 points, which means we need the x values of those 5 points. So my first x value is always the phase shift. In this case, it is 0. The x value of my last point, or where the cycle ends, is the distance from the phase shift, or taking the phase shift and adding the period. So if I take 0 and add pi over 2, then that's where I'm going to end. Not a lot of work when we start having a phase shift of 0. Okay, what I do have to do now is find the midpoint, the quarter point, and the 3/4 point. So several ways to do it. If you're good at fractions, you can say, okay, what's half of 1/2 pi? Okay, and that would be your midpoint. And then you've got your 1/4 point and your 3/4 point, or what we could say is x sub 2 and x sub 4, which would be the halfway between those two halves, the midpoint. So if you're comfortable doing that, totally fine. If that sometimes that's a little bit more difficult because of the fractions that we have, there's a procedure that we can use, and we can say, let's take the period and divide it into 4 equal parts. So we call it the quarter period, or basically what's 1/4 of the period. So we take 1/4 times pi over 2, which tells me that it is pi over 8. So each one of my 4 equal parts is pi over 8 units. So then I can simply just add going across to get the next x value. So if I take 0 and add pi over 8, I get pi over 8. And then I add pi over 8, I get 1 pi over 8 plus 1 pi over 8 is 2 pi over 8, which we should reduce to, pi over 4. But if you're adding, I just keep it with the common denominator and then reduce. So then I'm at 3 pi over 8. And then my last one I can double check would be 4 pi over 8, which should reduce to pi over 2. Okay, so these are my x values of my 5 points. So that's what I'm going to locate on the x-axis, and I need to make sure that I'm consistent with my scale. So I'm going to make, because of size, I'm going to make my 2 squares be pi over 8 just because of my writing, but That's up to you, whatever you choose. So I'm saying every 2 squares is pi over 8. So I have to be consistent. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So I know this one's 3 pi over 8. 2 pi over 8 reduces to pi over 4. And 4 pi over 8 reduces to pi over 2. So I label those. So I label my x-axis with my 5x values for my 5 points. I now label my y-axis to show the midline, which is the x-axis, so there is no shifting. So then I just need to mark the max and the min. Well, the max would be, I'm going to go up 1/3 because of size. I'm going to make 3 squares 1/3. So I go up 1/3 to the max and down 1/3 to the min, so I know that's the location of my max and min points. Now I have to think about, I'm graphing sine. So my sine graph looks like this. I've got these 5 points I need to locate. All right, so I have the x values for those points. Now I have to remember that I am reflecting. So I am going to go down to the min first and up to the max last. Okay. At the beginning of the cycle of sine, we're on the midline. We'll go down to the min, back to the midline, up to the max, back to the midline. So if I know the basic shape and location of those 5 points, I just adjust it according to my new x and y values. And there's the graph of the first cycle of this function. You could repeat that, another pi over 2 units to the right or to the left, if you need more. Okay, let's look at another one that's kind of interesting. Sometimes you'll see that your b value is a multiple of pi, all right? And that's fine, but what does that do to the graph? What looks different about it? So let's take a peek. So here I can see that I've got an a value of 4, which means my amplitude is 4. I am not reflecting because it's positive, so I'm going to do basic cosine, which would be this shape, and here's my 5 points. Okay. The period, then, that's where we're going to see something different. Okay, this is our b value. So our b is pi over 3, or 1/3 pi. We're used to just seeing that as a number not involving pi. But we do the same thing. We take the period of the basic graph of cosine, which is 2 pi, and we divide by pi over 3. But we have to be careful because we're dividing by a fraction. So remember, that means multiply by the reciprocal. So I'm now multiplying by 3 over pi. When I do this, I can divide out the pi's, and then I'm left with 2 times 3 is 6. So notice the period now does not involve pi. It doesn't have to, okay? Because even if it involves pi, it's a real number. And 6 is a real number. It's actually nicer to not have to deal with pi because it's what we're used to. Okay, so we have no phase shift, so our cycle begins at 0, and no vertical shift, so the midline is the x-axis. So if I think about my x values for my 5 points, I'm starting at 0. The period is 6. So the last point of the cycle will be have an x coordinate of 6. Okay, now here's where I don't feel like I need a quarter period, but you can if you wanted to. Okay, so let's think about this x sub 3, or what is our midpoint. Okay, so what's the point in the middle of 0 and 6? It's basically the average. 0 plus 6 is 6, divide by 2 is 3, and I think most people are comfortable with that. Now, what you could do to find your 1/4 point is, what's the midpoint between 0 and 3? So it's basically 0 plus 3 is 3, and divide by 2, so we get 3/2, or 1 1/2. Okay, and you could do the same thing here. What's the midpoint between 3 and 6? You're averaging. Remember, that's what a midpoint is. 3 plus 6 divided by 2, so we get 9/2. So sometimes I do this method rather than the quarter period. It depends on what I'm given. So you use what you're comfortable with. So these are the x values of my 4 points. So that's what I'm going to label my axis. So if my period is 6, then I'm just going to make each square be 6. All right, so here's 6. Halfway would be 3. Now, I am going, because I'm doing halves, I'm going to have to divide in half here. If you were able to make each one of those 2 squares, then you wouldn't have to do halves. It just depends on what, if you're using a grid or if you have your own graph paper, or you would have more squares than I do. Yeah, I'm not able to do that. So anyway, so this becomes 3 halves or 1.5, and this one is 9 halves or 4.5. Okay, so I've labeled my x-axis. Now I need to go with my amplitude to label my y-axis. So my midline is the x-axis, so I just go up 4. Right, I go up 4 to get to the max. I go down 4 to get to the min. Down here. All right, and then I do my basic shape of cosine. So I begin at the max. At the quarter, I'm at the midline. At the midpoint, I'm at the min. The 3/4, I'm at the midline. And at the end, I'm back at the max. And here is my first cycle of that function.